Welcome to Rubber Duck Engineering. Tonight, we're going to have fun with slide puzzles. We're going to do slide puzzles in Flutter. Hi, Dr. Barth.
We're going to solve them.
We're going to solve them. That's
We're
right.
going to solve them.
Well, all of this is in celebration of or in honor of Flutter, the team that I work on, is running this puzzle hack challenge where you build a pretty slide puzzle.
But I have no design all the rage. They're taking over Twitter. This Wordle thing, it's so like 2 episodes ago. Actually, the Wordle episode, somebody in the chat came and asked about the Flutter Puzzle Hack, and I didn't think we should actually go like do the Flutter Puzzle Hack because that didn't quite seem right. But this is like Flutter Puzzle Hack adjacent.
Yes, I do not have design skills to design any beautiful puzzle, but I can make them fast, and I can solve them perhaps. Well, we'll see if we can solve them tonight. But I figured this would be fun. Other things to say before we jump into it? We're going to try and get it all done tonight.
Hi, Alan. Thanks for joining us.
Hey, Alan.
No, I think we should dive into it.
Let's do it.
Hi, maybe Hal. Thanks for joining us.
Oh, before that, I wanted to show, if you haven't heard, Flutter, as I said, it's running this puzzle hack thing, flutter.dev/event/puzzle hack.
Anyway, this is a slide puzzle if you don't know what we were talking about.
Hold on, I can't hear you. Over the 12 seconds of really loud music.
And it's like a grid where it has a picture and you can like slide the squares into the empty space and you try to reconstruct the picture. That's it. That's a slide puzzle.
Yeah, so they're giving away a whole bunch of money. It's cool. That is the like example thing they base off of is Very Good Ventures slide puzzle. But I tried to get this one working on Windows and it depends on some like web specific plugins. So I stopped. And I used this older one from Kevin, who we've had on the show.
Yes, if you look back in our catalog, you can see our interview with Kevin. He does lots of really cool stuff. So.
He does. He has been on the Dart team for 85 million years at least. And this is his little slide puzzle example, which I think we even used it like a Flutter example event. Anyways, it's straightforward. It's got like some different. It shows off animations. And he's got this autoplay button, which I was looking at the code to see if he had ruined the entire show already.
By having already written the solver.
But then I looked, and what this button actually does is it just turns it into random play mode. So it's just making random plays, which is cool for demos, but not a real solver. So we could write a real solver.
So Eric, how do we solve this puzzle?
So I kind of don't know. And I said this to you in the before the.
Where's the we have no idea what we're doing banner? Because I think this is the appropriate moment to show it.
Yeah, I mean we who knows how we'll get tonight. But
we did do some research, and apparently there are a bunch of different algorithms people use, but one of them is A star.
Mm-hmm.
And there's a really nice
program before.
Yeah, we did in the pathfinding episode. It came up too. Mm-hmm. It turns out there's a really nice package on Dart package that contains the A star algorithm that's maintained by someone. Who's the maintainer, Eric?
Okay, so I'm the modern maintainer. I don't know that it's really nice or not, but it was the only A star Dart package I could find. It hadn't been updated in 7 years because the individual had left the team. And I dug it out and made it work and got them to post a null safe update. So it is now null safe and we could use it. It's literally A_star, I think, is the package name. A star Dart.
That was start a Dart bar. This is the danger of a live show. You never know what's going to happen.
There we go. It says a sample A star.
Simple.
And simple. Oh, you're right. Yes, I can't read. And I did work with Seth to get it updated. It was from this JavaScript example in 2013. So long time ago.
All right. So we should add it to our thing and see how it works.
Yep. So anyways, if I remember from hacking on the code, it has 2 flavors. it has just like a generic A star where you have to do some callbacks. You like subclass a thing, and then tell it about what you're A starring over. And another is that you just give it like a text grid. So if we do Flutter packages add A star, should just work. Hey, it's 1.0.
Does that mean the like non-null safe version had a version number less than 1.0?
Yeah, it was like 0.4, 0.0.4 or something like that. I decided to make it 1.0 as part of making it null safe. Again, this is from the like wild beginning days of Dart.
Yeah, I'm supportive of making packages 1.0. I feel like that's a good practice.
So now we have it. We could look at Kevin's code. This window is like really big.
We can probably put away the visual puzzle for a little bit while we hack on this.
Okay, I have more pixels now. There's a prayer. Okay, so if we look at Kevin's code and we look for auto play, I think it is. There's all this like times when it's like checking to see whether it's auto playing and doing something slightly different. I don't think we need to change any of that. The thing I want to look for is this, which is when we're in autoplay. This is on tick for some sort of animation. It does puzzle play random.
Okay.
And that's it. And so
can we look at the implementation of that function? I imagine puzzle is like a model class.
There's a puzzle animator.
Mm-hmm.
And it just clicks a random.
I see. And what is underbar puzzle? Like what type is that?
This is a puzzle type. It's an abstract class. Interesting. I wonder why it's abstract. I've never looked at this code before tonight, so we're...
Well, part of the fun of this episode is exploring a code base that somebody else has written, which is not something we've really done on the show.
So I will say one thing about this code base. I know, like Kevin has updated it to null safety and all, but parts of it I know were written a long time ago for the web version of Dart. So it's possible that it doesn't have all the latest and greatest Flutter idioms.
Looks like there's Puzzle Smart and Puzzle Simple, which are probably one of those might be a concrete.
I don't know what Puzzle Smart does. What's the difference between a Puzzle Smart? Extends puzzle with list mix in. Okay, let's go with Puzzle Simple. I wonder if he has a README. I bet a README might tell us these things. So here's Puzzle Smart and Puzzle Simple.
Mm-hmm.
README. Okay.
The README doesn't have a ton of information.
Didn't do it. Didn't do it for me.
You know, it looks like there's a lot of information in the abstract base class. Oh, hey, Kevin. Kevin is here in the chat.
Guys, this is the first thing I ever wrote in Flutter.
Well, we're digging through it to learn from your wisdom.
We're going to judge you. It's going to be great. No, I promise we won't judge.
Hi, Andrew. There's an interesting thing. There's a fitness function, which is it says a measure of how close the puzzle is to being solved. This is in puzzle.dart. And this is exactly what we're going to need for A star, because A star is going to ask us like how far we are from the destination. So fitness is probably exactly what we want for that. And right below that is click random. Clickable values. So I think we probably don't need to worry about the subclasses. It looks like all of the logic that we're interested in is here in the base class. It also looks like this follows the immutable model pattern that we've been using in our recent games. So I think this is probably where we should focus.
Click value. New with values. Oh, it totally does.
Oh, it's been migrated to like null safety and stuff.
What's Kevin saying?
This is what he started with.
This is why there are two impulse. Smart meant to be a small in memory. A bunch of solved versions in a big map.
Oh, I see.
Oh, were you writing a solver? Did you already write a solver and I just didn't find it?
High tech. So I think we should try to basically extend this puzzle dart file.
Okay.
Like that may not be the optimal place to put this code, but we can start off there.
Mm-hmm.
So I imagine we want to import something from the package that we just added, and then there's going to be some kind of thing we have to subclass from there.
Yeah, I suspect we're going to end up having a puzzle solver that's sort of separate, because if I recall correctly, I was trying to write an optimized solver to find the best possible solution, not just a solution. Oh, did you do so? But my recollection, and we'll go look at the A* bit, is that you have to actually type a sizable amount of code in order to like integrate with the A* algorithm.
Okay. I mean, does that.
But we can always move it to another new file later. Where was our play? Yeah, this thing. So it's like instead of click random, we want to call like a solve next. I got close, was hitting memory limits. Okay. You were saying, Adam?
Oh, I just added the import of the A* package. This is this like top-down, bottom-up, like coding style thing that we're hitting again. Where you want to go like top-down, like where's the button like, and I want to go bottom-up as like, okay, let's add the algorithm.
Well, I'm trying to like think. So this instead of play random, right? We're gonna have a play
solve, right? Like play solve or whatever.
Yeah, play to solve or something like that.
Mm-hmm.
And then instead of click random, this is going to be puzzle next to solve. I don't know what next random vertical means. Oh, this is some sort of like, I don't think we're going to need this. That was trying to alternate, I think, which ones we do. Okay. Click count, controller, add puzzle event. I don't know what a puzzle event is. Or we can leave it be random for now. You were saying?
I was just looking at the A* package. It looks like there's a graph class that we need to implement.
Mm-hmm. And there's an example. Ah, okay. All right, so we do want that event. All right, great. I think we're ready to add this. Yes, you and I do code in opposite patterns. It's okay. We meet in the middle. All right, so right here, we want puzzle next to solve. All right. Solution goes here.
Solution goes here.
Right.
To do the most powerful of all comments.
We were talking about implementing like a subclass to A*. It's been a while, like at least a month since I looked at this. There's an example. A* 2D is an example of
how to do this.
2D. I have to pull open the A* package itself.
This is the tiniest little file open dialog. You can tell how big Eric's screen really is, because apparently that file open dialog is a reasonable size for him.
Oh, it is. This is a very normal size. What am I? It's like Dart A*. I just don't know where it is.
Please look on GitHub. GitHub should have it, right?
Or I can get it from this thing. I just have so many. Why is this so hard? All right, well, fine. I'll get it from clone repository. Oh my goodness, it's way off the screen. My GitHub window is big. I feel like I've taken us off on a tangent here. Clone repository, github.com, A star, or A star. Okay. Oops. Okay. Here's the Dart A star folder, including an example, I believe.
Oh, there's some tests. Maybe tests is a good place to find the example. Yeah, look, there's in the test, A-star test.dart, there's a thing called simple node network extends graph, which I think is what we want. So we want something like puzzle node network.
What is I don't understand like how the idea of mapping a puzzle into a graph.
So for any given state of the puzzle, there'll be various moves that are legal, and those are the outgoing edges from that node of the graph.
Sure.
And then go to the next puzzle state will then be the state after that move. And then as you click around the puzzle, that will then forms a graph that you could try to search. So that the nodes in our graph are these puzzle objects.
Okay. Okay, so I'm just going to copy this.
Yep.
Okay. And then we can put it at the top of our puzzle here.
Okay.
We'll move it somewhere else later, but for now it's here.
I don't think we need.
Yeah, we don't need that one.
We do actually, because there's a node contract we have to abide by. So we can say puzzle node, node extends node. Okay. Connected nodes. Puzzle node.
I wonder what the A, B, C, D is for. I see. It's just like we're building up our network.
I'm just trying to delete the extra stuff here. Looks like node doesn't have a lot of contract. Because what do I need to implement node? I don't have to implement anything.
Node is just, yeah, this is just, I remember when fighting this, I tried to do my own A star and then I moved to the, A star wants to like hang a bunch of data off of your thing, which I think is what node is for. It's just so that it has the ability to hang data off.
Well, we probably want to hold a puzzle, right, in our node.
Okay, makes sense. Yeah, yeah.
Right. I guess this will be final. It's mad. Okay, fine. Okay, so then we have to implement. We don't need to implement this or this. At distance from one puzzle node to another. Okay. Get heuristic distance.
Yep. So I believe my recollection of A star, and you may remember better, is that the algorithm asks you, given these two nodes, how far approximately do you think they are? And the better your heuristic, the faster it will help it solve it. But it doesn't have to be correct. It doesn't depend on this being accurate.
Okay.
So you can just always return, 1 or whatever. Okay. I think if you always
I think this
do a first search or something. Go ahead.
We want to use the fitness of this. So our guess is going to be like node dot fitness minus goal node dot fitness.
Well, that's probably way expensive. I don't know how. Oh, interesting. Oh, okay, sure. Because the nodes are not the individual nodes in the puzzle. The nodes are the puzzles themselves, puzzle solve states.
Correct.
Okay.
And neighbors of. So we need to figure out all the legal moves from a given puzzle. So I bet that there is a something in the existing puzzle class that will help us with that?
I'm absolutely certain there is. The other one previously used it, in fact.
Oh, look, all movable.
It's like clickable values. Would be one potential.
But look, it's all movable, I think. It takes the clickable values and shuffles it. And then, click value. Click value will actually compute the puzzle for anything. So I think what we want to do is we want something very similar to all movable, but without the shuffle. So let's just do...
Are there other places that clickable values is called? Okay, I guess it doesn't exist. Okay.
So let's say adjacent.
Mm-hmm. Adjacent puzzles.
Puzzles. Okay.
LES, but yeah. I always do that.
And fix it. Okay. So get the clickable values and map it to map the click value. Okay. We want here in the neighbors, we want to say return puzzle dot adjacent puzzles, but now we need to map onto the puzzle node. So given a puzzle, we want to return a puzzle node for that puzzle.
Mm-hmm.
Oh my gosh,
it seems pretty expensive.
Is constructing a puzzle expensive?
I don't actually know. That's the thing we need to find out.
Okay.
What does it store? Width and height?
We can try it. Like, why don't we try it? And then instead of prematurely optimizing, we can make it more efficient.
No, I'm just sort of looking to see what it stores. Just gets.
So what is the contract? Like, what is get distance supposed to be? Is the...
Good question. Let's go look. A star, get distance. Given two adjacent nodes, returns the cost from A to B.
Okay, so the cost is always 1 for adjacent nodes, which is the one move.
Okay.
Okay.
And get heuristic distance, given two nodes, not necessarily adjacent, returns the estimate of the distance between them. The better the estimate, the more direct the search. But better estimates often mean slower performance. Search works even if the return from the heuristic is constant.
Optimize this first. Okay, so I feel like we've implemented those functions, perhaps not optimally, but at least in some plausible way.
To be clear, Seth was the original author of this. He translated a JavaScript example to Dart, again, back in 2013 or whatever. And then I translated a non-null safe Dart to null safe Dart after having done my own A star and it had been fit. So like there hasn't been a lot of optimization thought into this.
It's fine. We're just trying it out. So what do we do with so we got a graph. Like there must be something in the A star library that uses a graph.
A star library that uses a graph. Oh yeah, you just let's go check and see how it's how do I close this? Let's go see how the tests do it, because I believe you just like make an A star. Yeah, you just do an A star of the node type, and you hand it the graph you want to solve over.
Okay, and then there's like a solve it for me.
And then there's a find path sync.
Okay.
Pretty straightforward.
Okay, so we're gonna need a goal puzzle. So we're gonna need like a completely solved puzzle.
We also want to stash this for any given.
Do we need to like return the same node object if like you go forward and backward?
I think we want this to like be a global, I guess is what I'm saying to start with. You don't want it to be on the puzzle itself.
Okay, like a solver. You want like a puzzle solver class?
Yeah, I think you want like a puzzle solver.
Okay, let's make a puzzle solver.
That ends up being held at a longer lifetime than any given puzzle object.
Okay, so it's got some state, and it's got a like puzzle solution, like solve, and you give it a puzzle. Okay.
Uh,
What is a puzzle solution? be like a list of moves, right?
Okay. Yeah.
Okay. Inside
This
solve.
is the part that's really expensive. You don't want to like call it again. So this could be on puzzle itself. You just don't. You like wouldn't want to call this repeatedly. You want to call it once. And then
You want to call it once a plan, and then the animation should just run through the moves. And
correct.
okay. So this thing is going to somehow construct a puzzle network, right? Okay. Puzzle network. And then what did I do? There was something. You had the code from the test that we should copy and paste here.
Yeah, this is just final A. That should be it. And you want something like Dart puzzle solution, which is going to be like a star dot and path sync.
Okay, so we need to make a goal. So I'm going to make a constructor on puzzle that gives you a solved puzzle. Factory puzzle dot solved.
Mm-hmm.
I guess with a width and a height.
This is going to give us a path of nodes.
Yeah, so we'll have to work backwards to figure out what the moves were that made that happen. Okay. So random list.
I don't know if this thing has the concept of a move. It must.
Okay, so it's a random list. I want.
I see. It treats them as a click. They're just ints. Okay. Yep. Oh. Interesting. I think we want to save the coordinates rather than the.
That makes sense.
Than the tile. I don't yet know what tile value is.
Okay, so I believe I've created a constructor for a solved puzzle. A certain width and height. I'm going to go up to the goal, set that as a goal object. Goal equals puzzle solved. Puzzle dot width, puzzle dot height. Okay. And the start is going to be just the puzzle. Okay. I'm back with you. Can you get me up to speed what you're looking at?
So I was trying to understand how it handles clicks. And it appears that the way that it deals with a click is it passes around the value to click on. It deals with either like points in space, points in the grid, or the value to click on. And so I think that a move between puzzles is going to end up recorded as the value clicked on, which is okay.
That's okay.
So
you're saying when this function where we call adjacent puzzles, maybe we just want to get clickable values? Like instead of doing the adjacency here, we can do the adjacency here in the nodes.
I'm not sure I follow where you. I was working on this or making our puzzle solution. Where did you go?
I was looking at neighbors of.
Okay.
So we could say like final clickable is the clickable values.
Yeah.
And then in order to create puzzle node, we could say click like value, right? We can pass the value to the puzzle node as well as the puzzle.
What are we trying to do?
I'm trying to basically memoize the value that we clicked on into the
into the puzzle node.
Yeah.
Oh, so yeah, sure.
Click value for value. Okay. And then puzzle node, where is it up here, can have a
Yep. Value. I like that a lot.
Then we can reconstruct the path very easily.
Yep. Okay. Yep, I like that a lot. Okay.
I feel like I did something wrong here.
I swapped out your.
Click map the value. Puzzle node.
We also had a whole bunch of errors beforehand, so I think we should address those.
Oh, okay.
Argument type puzzle cannot be identified or cannot be assigned to the parameter puzzle.
Oh, no. we need to make a like a node here. Puzzle node.
Oh, but we won't know what value you clicked on to get to the puzzle node.
That's true.
That would suggest that the value is not the, you don't actually want to, because that's the move that it took to get you there.
Which is the thing we're trying to figure out. So maybe we shouldn't do that. Okay.
This is not, yeah.
Okay, I'll unwind that then.
Yep.
Okay. But we still need to make a puzzle node out of the puzzle. Like start. Start a puzzle node. Puzzle. Okay. Then we can start from there. Okay.
Okay.
What's the next error?
One, we haven't constructed our puzzle solution.
Okay.
We can just put this as empty for now. Expected to find, yep. About to do it. Value type dynamic. Why is fitness dynamic?
Oh, it should be node.puzzle.
Ah.
Let me get rid of this underbar here. Okay.
Okay. And this is the same thing. This is going to be.
Oh, right. This is going to be like node.puzzle.
Okay. And that's because puzzle itself is a question mark. Oh, just from click value, right? This is going to be final. Next, this. Oh, I see.
Yeah, I think because it may not be a legal move, but we're just going to assume that legal values gives us something that will work with click values.
An unexpected return.
Okay.
Okay. Ordered list. What's this?
That's I just made up. Yeah.
Okay. Local value nodes is not used. Yeah, fine. We haven't done that yet. Parameter node should have a name A to match use an overridden method. Fine. B. So that's a wild lint, but sure. Okay, we're good. We're caught up.
Okay. So now we just need to back compute from the list of nodes what the moves are. But we can just, that's fairly easy, right? We could just say for
given two puzzles, we have to understand what is the move that is between them.
Yeah, but that should be straightforward, right? Well, I is less than nodes dot x multiply. We'll just say we'll take start is nodes I left right nodes 1. It's actually length -1 because we don't actually want to go all the way to the end. Then we just need to say, what is a queue?
So question. The answer to this is whatever one you clicked on is now the new open square, right? But a single click in this, as this is defined, can move multiple pieces.
That's fine.
So you actually can just look at right.open and then look at the position of that in left, and that is the value you clicked on.
What?
Did I do that right?
You just blew my mind, but I love it. Right.puzzle.open. Okay.
And here I thought I was the color commentary.
Open slot. And then in left, how do you look it up?
I mean, it should just be like, oh, yeah, it has like a coordinate at. There's this is the thing.
Supply that.
I saw this stuff. Open position is what you want.
Okay.
And then there's it's like a value at. Yep, value at.
I love it.
Although it returns you a point. What does that mean? I think Kevin, as well as every other person on Earth, wants a darn int point standard in Flutter somewhere.
Oh, value at X and Y. Okay. And what does open position return you? It returns you a point.
It should return.
What is a XY?
Yeah.
Okay. All right. So open position X
interchangeably, but I'm not sure.
Okay, that's legit. Then we want to basically moves is just a list. So it moves that add value. And then we can return this.
I'm not sure what I told you is actually going to work. The thing that seems to be troubling is whether this is a coordinate or an offset.
Okay.
Yeah, I think instead what you're going to want is index of.
Okay.
The open position returns coordinates of tile count. And I think tile count is used as the magical open position. So you're going to want index of tile count.
Okay.
To get the open.
So is it open index?
Offset, basically. I'll just give you that function. I'm going to give you open offset.
Okay.
Int open offset.
An offset. Okay. And then how do I get the value at an offset?
What'd you say? How do you get a value? This is all here. How do I make this disappear? Does this work? Collapse all. No. Go away. I'm just reading his code here.
This is the fun part of exploring somebody else's code.
Value at is based on those, which, yeah, value at is what you want. Oh, except that gives you the. Oh, I see.
Which is this. It's like this. The subscript operator gives it to you.
Get index.
Yeah, it's operator bracket. It's operator bracket gives it to you.
Okay.
Okay.
What is coordinates of? I see. Index of is what you want. An offset of. Okay.
Okay.
Open So open, this is turning to open index. Open index, the index of tile count. Great. This is tile count is used to represent the open tile. Okay.
Yeah, so the only problem is that the solver returns a queue, and we want to turn the queue into a list, which I think we.
The solver returns a queue.
Mm-hmm.
Okay, and there isn't just like a toList button function.
It looks like it's iterable, so
toList to work.
toList should work. Okay.
Yep. What's it mad about here? Operator isn't defined for queue. Okay, sure. Open offset isn't defined. No, it's open index now. Omit type annotations for local variables.
Okay.
Fine.
Okay. So theoretically, I think we just did it. So we need to. It's going to blow up in our face.
Well, ship it.
But
it's true. This isn't Rust, so it isn't going to work on the first compile.
So I think back in the UI, we need to have some sort of state that when you first ask it to solve, it needs to like make a solver, call solve on it, remember the solution, and then as it ticks through, just make the moves in the solution.
Yeah, exactly. So solution goes here, right here. Oh, yeah, but this is not what we want. So I'm going to delete that.
Yep.
Okay. Okay, so this play to solve.
So we're going to have a puzzle solution there.
Somewhere in here. Is this a long-lived thing? Implements puzzle proxy. It holds a random, so it presumably is decently long.
That looks pretty long.
Yeah, this is long-lived. Great. Okay, so this is stateful. All right, so we want puzzle solution, question mark, solution.
Yep.
Okay. And how are we going to know which one is the next? Do we have to like...
we could just pull it off the front, like pop front or whatever.
Okay. There's also some code in this controller when we add an event. So I went looking for where this is used. It's puzzle event random. And this is only ever used to like disable the autoplay. It's like if we ever get an event that's not random. So the random is really like, did we do it ourselves? It's an autoplay event.
All right, but I think we just do this in this play to solve function. We can totally just do everything here, right? You could say, if the solution is null, then we need to make a solver. Solver equals full solver. Okay. We need to then set solution equal to solver.solve current puzzle. Okay. And then the puzzle we want to do is how do we make a move?
It's like, well, what's this? Click or shake?
Click or shake.
I don't know what shake does.
Shake probably like randomizes it.
No, that's not. That is definitely not what we want. It's look up here with play random, right?
Yeah.
What it does, it just
click random, but there must be like a click something specific, right?
Oh, sure.
Like a click. Is there a click value?
Yes.
Click value. Okay. I feel like you're sort of mixing up the metaphor. Like clicks are not necessarily things that model objects should know, but whatever.
As he said, his first Flutter code over, he never expected it to be contributed.
Next move, right? Next move value. Now we need to implement next move value.
Okay.
On the puzzle solution. So int next move value.
A thing that I would want like a sanity thing you'd kind of want in this is you'd want the puzzle solver to remember what the expected like puzzle state is right now. And so at some level, maybe you want to just say solution, hey, here's my current state. What's the next one to take me to?
Say that again?
The puzzle, I feel like the puzzle solver you should hand it the puzzle, basically.
Okay.
And that's like my current, it's like, hey, I'm here. Give me the next move. And then it can do the caching and stuff for you. It can also then validate and be like, blah, you handed me a state that makes no sense, not along the solved path. I'll resolve a new path for you.
Oh yeah, that's a neat idea.
I don't want to take us away from like getting further, but like.
Yeah, I think that would work really well. But I actually like the robustness of that. I think the thing that is typed should work.
Receiver can be null. Sure. We can just bang you. There you go.
So basically what I did is if you go look at puzzle solution, I just cached the index and then it just marches along the index.
What? So let's see.
Yeah. But I mean, what you're right is that this approach is very error prone because we create a bunch of ints and then we like machine gun through them without validating them. And it'd be way better to just like present the puzzle to the solver.
Clicks to stop it and then starts it again. Like.
Yeah, no, I totally agree with you.
Okay, what is this? Play random. Do we have play to solve? Is that ever called? No.
No.
Oh. So this is the one place. Okay, fine. Okay. Done. Sold.
I have a feeling we may want some like log statements or something because I suspect if we just click this button, it's going to go to sleep for forever. And I guess we're in the debugger, so we can stop it in the debugger and figure out what's happening.
What, you don't think our code's going to work perfectly the first time?
You know, it's never happened before, but that doesn't mean it's not going to happen this time.
Ye of little faith. Okay. How restart complete. Boom.
Okay.
So we click autoplay and
see what happens.
Yep, it went to sleep.
Okay.
It's still thinking about it.
Maybe this is why there's an async version of solve so that you can put up some spinners or something while it's grinding away. Can we like interrupt it in the debugger and see if it's?
Well, I worry that we're going to hit what Kevin hit, which is like we're just going to run out of memory. We are stopped in the debugger. Why will this not? I see. It's like, I'm sorry, dude, you need more pixels.
You cannot be so big. I think we can jump inside unknown source. Can we go deeper in there? Like, I think it's helpfully trying to collapse.
I think there's a like debug my code and then like all code or something like that. There's like a setting in the Flutter debugger, whether you're debugging your code or everybody's code. I don't remember where that is.
Okay, but it's clearly trying to solve something. Like this is a reasonable call stack to see if it's just grinding away.
Sure, we just would love to see what.
So I have an idea, which is in get distance, we could add like a logging statement to see what the fitness is of A, and then see if it's going down at all, and if so, how fast.
We also could have this thing load up with like a very simple thing that's like 2 moves away from being done.
Okay. Yeah, you want to try that? That's sort of an optimistic thought process.
Well, that might help answer the question of, is it just going out to lunch because, you know, it's using infinite memory to take all this?
Okay.
What is this? Oh, this thinks I'm in like, because it thinks I'm running a Windows app.
Oh, Tech was also thinking of making an autosolver. Yeah, maybe you'll see us flame out horribly and it'll inspire you to actually make it work.
All right. So what are we doing in our remaining 10 minutes?
I think we should try it. So I guess we'll try to solve the puzzle manually till it's a couple moves away, and then try auto solve and see if it succeeds.
I wonder if we could
I think that's slightly unlikely to work, but
well, I bet there's a way to seed this with a value, right? Like if we.
Oh, that's easy to do. You want the random puzzle to be an actually solved puzzle?
Yeah.
Yeah. So we'll just take this the normal puzzle constructor, and instead of doing random list, we'll call ordered list.
Well, except we need to make it slightly not solved, because otherwise it'll be solved.
Yeah, but that you can do through the UI.
You can't. I don't think. Well, we'll see.
Oh, we can also just swap one of the lists.
Yeah, exactly. All right, so let's try that.
Let's see. We think we need to solve first row. Yeah, so there are smarter solving algorithms, and that's totally true. That do things like divide the puzzle in half and like solve the bottom half first and whatever. So we were going with sort of like the big A-star hammer. See how far that got us.
Did we not show the?
We have no idea what we're doing.
Banner at the beginning of the show. I am amazed sometimes how much we do get accomplished in our 45 minutes of hacking on a Thursday night with no prep.
Can you mess it up? No, you can't mess it up. Okay, so let's just swap two things here. So we've proven the theory that this is the constructor that actually constructs the puzzle. And we can just take our list.
I think you can also just do puzzle raw and then just, oh, I see, you won't be able to.
Oh, yeah. Oh, check this out. I can say puzzle equals puzzle raw.
Yep.
And then what I can actually return is, so I should be able to click on the 13. Right? Click.
Yep.
Value 13. I'm going to get two moves away, right? And I'm going to click value. If I click on the 13, I click on the 1. Okay. Let's see what that does. Oh, it's sad. Why is it sad? Oh, I need more bangs. Insert more bangs.
Ah, yes. Bangs will continue.
I've inserted the bangs.
Okay. That doesn't look right.
That's not what I expected. But it's because there's 0 indexed in the code and 1 index in the display. So we clicked on the 12, and then we clicked on the I see. Okay. There we go.
All right. That looks much better.
Okay, so we're supposed to slide up and slide over, and let's see if the solver can do it. Go, solver, go.
No.
It was a dream. It was a dream.
Wow. Okay.
Yeah, the divide and conquer algorithm is supposed to be much more efficient than generic pathfinding. That's what some website I read 5 minutes before the show told me, but it also sounded harder.
Oh, okay. I again had no idea how to do this coming into this.
But I think we're pretty close. I think we probably won't be able to solve it in the next 7 minutes, but I think we have the structure in place to then debug it and then have something workable.
I also wonder if
your video is amazingly glitchy. You may want to kill this program that's consuming your entire computer, trying desperately to solve the puzzle.
Can you even see me?
You're speaking, but your mouth is not moving. It's kind of a great magic trick.
All right, so you're telling me I need to kill this?
Yeah, if you want to talk, you may want to kill it.
Details. Okay. All right, so I think we're closing.
Yeah,
the code machine.
Yeah, I think it's a good stopping point. Like, we're not going to solve it in the next 5 minutes, but maybe we'll come back next week and poke at it some more.
Okay, I think that was fun.
I feel digging into Kevin's project. Like that was cool. Like, this is like more like what my day job is like, where you have this enormous code base that was written by somebody else, and you're trying to poke and prod it and figure out what's the difference between an index and a position and a value. They're all ints, and you're like, okay, I think I got it now.
we might have a rogue special guest very briefly.
Ooh.
We'll see.
Yeah, maybe next week we should try to do that.
Oh my goodness! I heard a beep. We're towards the end of the show, but we could slip in a little Kevin.
The kids are now in bed. I can't believe it was like Eric sent me a message. I don't know, when I'm running around like leading kids to basketball practice, like we're showing your code. I was like, wait, you made this mistake once already. You're not going to do it again, are you?
We will make this mistake as many times until morale improves.
So I probably spent a week trying to solve this, like of work time, and I shouldn't have told Tim. He thought I was polishing the demo for the Flutter web launch, and I was like, I'm going to solve this. So yeah, I implemented A-star as a branch. It's all old code. I can't get it working. Do you want like the little story of what I kind of figured out?
Yeah, what did you figure out? Like now, clearly after we failed that.
So if you notice in my code, there's some crazy fitness function.
Yeah, we found it. Yeah.
And so the idea is, so what I would do is you'd start with a start puzzle, and then you say, okay, given a square that's clickable, there's at most 4 other states to be in, maybe 3, maybe 2, depending if it's a corner or not, right? So I would say, basically you want to crawl towards the right state, right? So you can imagine every node, you probably talked about this, I was putting the kids to bed. Every node is a puzzle state, and every edge is a click. And you want to get from your starting node in the graph all the way to a solved puzzle. And so what I did was I think it ended up being A-star. So I would explore the graph, and I would add nodes to a graph, literally like a linked hash map. And that's why
I'm trying to actually reify the graph.
So this is why I'll get to it in a second. So if you just do because you don't want to backtrack. So what you do is I would keep track of every place I visited, because you get in a circle sometimes. You find a cycle, and you don't want to you could do the same move over and over and over. So it's like, oh no, I've already been there. I won't visit that node again, right? And so I would slowly do a depth first search.
So I think that's the problem. I think that's the problem in our algorithm, because we're minting new. So we're using an A-star package to do roughly what you described. And I think every time we explore a new node, we make a new node object, which means we're never the algorithm is never detecting a cycle. So I think we need to add a catching layer so that we then return the same object. So the algorithm's like, oh, that's a duplicate. I don't have to keep exploring down that path.
So that's why if you look at Smart Puzzle, it's insane. Like I optimally encode the state of a board in a uint32 list, so that it's the smallest possible thing. I actually benchmarked to see, because you can bit splice across U8 int list, whatever, and I actually figured out which one was most optimal. So I pack a board into the smallest possible thing, and then I can convert that and create a hash code out of that fast. Because if you look at the algorithm, you spend the vast majority of your time just running hash codes, because you're adding so many items to a list. So I know you're running out of time, but I'll be brief. So I would find a solution doing this, and I want the best solution. So what I would do is I would explore and populate this graph with all these nodes. I'd find a solution, and I knew the quickest path to that solution. I think that's A-star, right? The quickest path. And then I would prune the graph and delete every node that was a path from the start that was longer than the path to the solution, because I know the best solution is less than those. So I'd prune the graph so the graph was smaller. And then I'd go searching for a solution that was shorter than that. And so I would go, find a better solution, a solution in fewer moves, prune the graph of all the paths that were longer.
This is
again. And it was if you actually look at one of the branches I have in my source code, I actually made a custom implementation of map that exposed effectively what what's the factor? There's a factor in a hash map. The collision factor or the
load factor.
The load factor. So basically, I was at the point where it got to make it work. Like the time it would take just to resize the graph, like the number of nodes I had, I was looking at insane amount of time just waiting for the graph to resize. And so I was optimizing load factor. That's why I used hash map. So the next thing I was going to do, and I was waiting for it, is now we have extension members. I was going to get rid of the puzzle class entirely and just have puzzle-like things on U8 int list, because I noticed that in my benchmarking, just the cost of the indirection of going from the puzzle object to the U8 int list, finding the hash code of that was causing problems. So I was like, let's minimize the indirection. So actually, there's a feature that's proposed in Dart, which is it's something kind of like type def or type aliases. where I can say the puzzle is UID8 list, like in the heap, it's a UID8 list, but pretend it has this interface. And I wanted that because then I could have like this optimally packed list. So every time I went to the hash map node entry, it was a one jump to where the data was instead of two jumps, because it started to matter when you get to like a map with 100,000 or a million entries in it. I was working on my dev machine because it had more RAM. Anyway, it's a really fun problem to solve. Like I got into like the depths of data structures and the cost of memory dereferencing, and it was fun. Now I have to bring it all back and make it work.
That sounds like an amazing journey. Thank you for sharing.
And I never got the solver done. I was like, okay, got to go to London and ship Flutter for web. But it was, yeah. Don't tell Tim. This is where Eric, you're a product manager, Kevin.
Totally not recorded across 3 platforms. I promise.
No, I'll have to go back and see if I can get it working tomorrow. And that's now I ruined another work day. I was like, oh, I have to go call A*.
We have effectively nerd-type views. What you're trying to say?
Yeah, for something completely unuseful. Like, I mean, I think if I got the solver algorithm out, I think people would have fun playing with it. And there's an interesting write-up just in terms of thinking about just computer science concepts. Like, most people don't worry about, am I using a linked hash map or whatever? Like, at a certain level of performance, the cost of a memory reference or the type of map structure you're using or the speed of hash code really starts to matter. Like, it's interesting.
We had another commenter with another solution similar to what we saw before, but this is a sort of divide and conquer. Right? Do a row and a column. I also wonder if the thing that one is solving for is maybe not the best solution, but rather just progress in the solution in the animation frame that you have. Like, I wonder if because right now the problem with the current autosolver is that it basically never ends. The like random thing, it's never going to find a solution, right? But if you could just simply change that so you could envelope so that it will eventually converge to a solution, right? I think that would be a major upgrade.
Yeah, I gave up Flutter. Like, I did it all in a console with insanely ugly like matrix style, just insane debug output. Like, it's completely unintelligible because like exactly this. If you're looking for the best solution, you're just spinning, right? So it's like, might as well just dump it in the console and not pay the startup cost of Flutter. So it's comparing user experience versus not. So you notice the thing I shipped was just play random. That was it's like, okay, I can't, if I can't ship the absolute best solution, fine, I'll just click around randomly. I'm not going to do anything. So thank you for entertaining. I wanted to give some color commentary if people are looking at my code. I'm curious to see if other people solve it. It's a fun problem.
Sounds like at least one viewer has.
Awesome. Now the trick is how you find the best solution. That's the next thing. So yeah, start with a solution, of course. Anyway, I should go to bed, gentlemen. Good to see you. I'll let you do your closeout. Thanks for including me.
Yeah, thanks for joining us.
Our first ever impromptu guest.
I love Kevin. He's wonderful. But it's been really interesting that you could see the intent like latent in the UI, right? And then there's a whole story behind like how did the autoplay feature become the random feature instead of the solution feature? It's fascinating. This is actually, I think, a fairly common pattern. If you want to contribute to open source projects, you'll find a thing that's like an obvious missing hole. And there's usually a reason why it's a missing hole. And like often you'll find a story like that.
Well, this was fun, as always. Any closing words? Amazing pizza this week?
Pizza is next week, but yes, it will be amazing.
We made pizza. I made pizza this last week. It was incredibly stressful to do it for the very first time, but I survived.
You toss the pizza in the air?
Did not toss the pizza in the air. Did do the slapping technique.
Oh, the slapping technique.
But mostly it was stressful. The tutorial is super verbose, and so I was like trying to scroll through 15 pages to find the one thing to like whatever step I was on. So.
I think you're trying to like answer every possible question. Like everyone who's ever taught who made a mistake, like that added one more sentence to the tutorial, and the result is the tutorial is enormous.
Yeah, but it'll be much easier the second time, and maybe I'll make. I think I'll probably make pizza next week. So, anyways, wonderful to see you. Wonderful to see you all. And
thanks everyone who joined and participated in the chat. It's really great.
Yeah, so wonderful to have so many folks contributing tonight. So, anyways, have a wonderful week.
See you next week.